Hello everyone.
Hi.
Hello.
Yeah guys, good morning.
Hey, hi Sankalp. Hi, hello everyone.
Hi Shubham. Hello everyone.
Good.
So like do
Just
we have full
asking,
house
just
or
putting a reminder. Like we'll
yeah.
start around like 8:11:05. Okay.
Yep.
Okay. Just allow me. Yeah.
Yep.
Very good morning.
Yeah. Let's start. Sankalp. Yeah.
Okay Shubham. Yeah. Thank you. Thanks Shubham. Yeah. So I joined from two accounts. Like one thing is I'll be using my uh, tablet to share the screen. Just a minute. We may have some. We might incur some logistic issues, but yeah, we'll see how it goes. So cool. I think screen is visible to everyone, right? Can someone be just kind enough to just say either yes or no? Oh, okay.
Yes,
Cool.
yes, yes, it's visible.
Yep. Thanks for confirming. So once again, guys, good morning, everyone. So this is Sankalp here. So if you just want to see my face, just a quick hi to all of you guys. Okay. So yeah. So let's start with my introduction first, right? And before I start with my introduction, I would like to thank Shubham for coordinating this. So yeah. So I'm Sankalp Saxena. I'm working as a senior like platform engineer in a company called Arctic Wolf right now. So earlier I worked at Rubrik. So I have been uh, I've been in this software development and in this DevOps era for like since last 10 years mostly. Like yeah. So earlier I joined a company called Hashtin where I was working on some developments, parts of it, creating some REST APIs, right, through Fast API, Django, and all those kind of stuff, and worked on like multiple databases, SQL, NoSQL, and all those things. Okay, so I've done all like this development for 2.5 years at this company, and then like I knew how to create softwares, but there was one problem that like how we ship these things at scale, right? So there was so like there I got to know, okay, there's something called as DevOps. There I got to know about multi-cloud, on-prem, all those sort of things, and that's when I pivoted to DevOps. And then I joined Rubrik, where I worked on this multi-cloud stuff. So it included first like on-prem, then AWS, GCP, Azure, all these cloud, and I dealt with a lot of clusters, Kubernetes clusters, like create like containerized lot of applications, dealt with CI/CD and whatnot. Like so, I'm coming from that background, and in my current organization, I am leading a team which is basically AI platform. So there we are like as you know that like shift is happening towards AI agents, right? So the thing is, every company is interested in having a platform, and where they can automate some of these like common work through like with the help of like LLMs, right? So here we are building like sort of fully fledged platform so that our customers can deploy application with the help of this LLMs, right? And they can get their job done, whatever specific thing is needed, right? So that is pretty much a small background about me. So yeah, I started as software engineer, then worked in DevOps. Now I'm like working on AI stuff, including DevOps and software engineering, all the aspects basically. So that's what that's all about me. So next thing is, why are we here, right? So as everyone says that paradigm shift happens like earlier it used to happen every 10 years, so new technology keeps on coming, right? So if we see back in 2000, right, like a lot of folks were like I mean everyone is deploying application onto on premises, right? So that's how like applications used to run earlier, right? Then came something called as virtualization, and then with early like 2010, we have this AWS, and all the cloud providers came into existence, right? Then everyone started shifting their workloads from on premise to, let's say, cloud, right? It could be anything. It could be AWS, it could be GCP, it could be Azure, right? Now the thing is the now again the shift is happening, right? So earlier we used to create normal softwares, right? Like I mean we used to write softwares with the help of engineers, right? Now we have LLMs in place. So the era which we are living on is agentic era, right? Or AI era, you can say, correct? Where now writing code is not a big deal, right? All the LLMs are capable of writing code, and they are like really capable of writing production level code. Yeah, so everyone is heavily relying on AI. So every company is heavily relying on AI. So this is the need of the hour. So that's why we are here. Okay. So we just want to pivot ourselves and move on to some of the and see some of the agentic aspect, or how we can write our own software with the help of this LLMs, right? And we can write some agent that can perform task like they can automate some of the redundant tasks that we used to do right now as a human, right? So so we came with this course called Drishti Bootcamp. So let's walk through what we are going to build. So we are going to build Drishti. Again, I'm a big fan of using Hindi names in tech. So which is nothing but AI Kubernetes diagnostic agent. Okay. So now, I've got to know that from Shubham and team that we are here with we have a very diverse audience, right? So there, I assume there are folks who are purely software engineers, and there are folks who are purely DevOps engineers, right? So, and both of them, I assume are trying to get into the AI uh, AI era, right? So I assume everyone is using Chat GPT, right? So which is nothing but your Gen AI, right? But most of us don't know how to create our own custom application with the help of Gen AI, or on top of Gen AI, which we call as agentic AI. Okay. So yeah, with that being said, before we dive into the agenda, I would like to first clarify my target audience. Okay. So you might be thinking whether am I the right audience for this course, right? So doesn't matter if you are from a tech background. So the thing is everyone is covered. There is something from that will learn, that everyone will learn. Okay. So mostly you will get all of the key aspects of building an agentic application, and how what are the key terminologies in the AI era, and how you can build your own application, right? So if you are from technical background, that's great. Even if you are not from technical background, that is also fine, because the thing is, whatever I am gonna teach you in the next sessions, throughout the sessions, I will take things from very fundamental aspects, and we are going to build on top of it, right? So if you join the classes regularly, and if you revise all of these topic whenever you get a chance, you are good. So there's nothing like that if you are even from non-tech background, right? If you are, let's say, you are you are doing some IT work, right? And you don't know about the some of the key terminology, so don't worry, I've got you covered, right? So I'll first cover all the fundamental aspects, and then we are going to build on top of it. So I hope that that answers some of your question, right? Like if you are having this confusion. And yeah, so before we move on to how this course will help you, let's deep dive what we are going to do in this boot camp. That will pretty much give you a lucid explanation, or lucid justification that okay, yeah, this is what we are going to do and how it's going to help me. Okay. So as I said that we are going to build Drishti, and what is this? So this is nothing but an agentic AI application, okay, that is going to help us in diagnosing the issue on the applications that are running on the Kubernetes. So what is Kubernetes? Kubernetes is nothing just another compute platform, or you can say container orchestrator. So I'm sorry if I'm throwing so much jargons right now, but yeah, just you can hold your horses. So once we deep dive into some of these things, so it will make sense. eventually. Okay, so it's nothing but a compute platform or a distributed platform or to run your applications at scale, right? And so yeah, so basically in any real organization, I mean, this Kubernetes is heavily used. You go to any org, they are using Kubernetes. So like more than 97%, like every organization is heavily relying on Kubernetes, because right now we have microservices and every microservice is containerized, and we have to have an orchestrator in place to to see what's going on in this application and how to manage this application deployment at a scale. So that's where Kubernetes is coming into existence, right? So as I said that companies use Kubernetes, so they use multiple clusters, and one cluster can even contain 1,000 nodes. So you can visualize something like that. So this is your Kubernetes, and these are the nodes, or the worker nodes where you have deployed your application. So there is your application running, right? So these are your application pods. So in Kubernetes, we have this terminology of pods. Okay. So let's say, so this is what you are running, your application is running, and for some reason, right, this pod crashed, right? So there is an error in there is your service went down, right? This pod went down. So there is one way, like let's say if you are from DevOps background and if you know about Kubernetes, you can just log into the cluster, get the status of the pod or the deployment, right? And you can just fix the issue, right? You get to know it because you know the meats and potatoes of Kubernetes system. Let's say if you are a manager, right? Or let's say if you are a software engineer who know how to write application, and you have written some of the Helm chart or let's say YAMLs to deploy the application on Kubernetes, but you don't actually know, right, how to actually debug it, right? You know some create command, but you don't know how to inspect the things, right? So what you can do is whatever we are going to build, the application, this Drishti, right? So this will be powered through an LLM, right? So LLM is nothing but your foundation model, which is GPT-5, let's say 5.1, Sonnet 4.6, right? So this will be powered through any LLM provider, and Drishti will be connecting to your Kubernetes cluster. It will get the context of the applications that are running and the applications that are failing, get the output of this, and then it will smartly analyze and it will give you the response that okay, this application is failing because it is because the error is home killed out of memory, the application went out of memory. So this is how you this is what you are going to build. So basically it will be more like a chat kind of application, so where you give it a prompt that I have this application deployed in Kubernetes, and right now it is not reachable or not running, so can you please debug? So it is going to give you the output, okay, this is like the application is failing because of home killed. Excuse me. So yeah, so I hope this gives you pretty much a basic idea, right? That what we are going to build. So yeah, so basically a small chat interface sort of thing, which helps you magically debug your Kubernetes cluster. I mean, application or workloads running in your Kubernetes cluster. Correct? So yeah. So let's talk about the skills that you are going to get out of this bootcamp. Number one is agentic AI, right? So we have something called as Gen AI, correct? That everyone is using. You might have used ChatGPT, you might have used Perplexity, right? You might have used Google Gemini, right? So all of these are Gen AI applications, right? So the thing is, we have this LLM, like large language model, which are trained on billions of parameters, right? And the thing is like billions of parameter and on like a training data set, right? So it can be images, it can be text, videos, whatever, right? So all of these training data set we use to train the models on different parameters, and we get an LLM, right? So these are really smart, and this is something which Anthropic, Claude, right? All of these folks from OpenAI are developing, correct? So they are very good. So how, like internally how they work is like they have like a lot of vectors, correct? They have lot and lot of vectors, I mean like billions of like vector, right? And then the thing is like whatever prompt you give, right? Okay, sorry. So let's say these are the vectors, right? So everything works in the form of vector in the LLM, right? So this vector contains some data. This vector has some information about the data. And let's say you give a prompt, correct? So you give some prompt, okay, explain Python, correct? So this gets converted into a vector, right? So this gets converted into a vector, and then like there will be like sort of semantic search that happens, and based on these things it generates a new content. Okay, so Gen AI basically creates like it's sort of application, or it's a model that generative AI model like generates new content with its own previous knowledge, right? So it's very great at creating content and suggesting you some of the nearest matches. So that's how, like that's what is Gen AI, right? Now, what is agentic AI? So agentic AI is something that like that is something like you create application with the help of this LLM, right? You have a LLM as a brain, correct? That already has like a lot of context, and which is very good at generating data. And then along with that, with the help of tools, or let's say there's something called as MCP. We are going to look that later. So with the help of tools, you specify your own specific data, and with the help of RAG, you specify your own custom data, right? Because we know that the LLM is trained by this Anthropic, OpenAI, right? So let's take one model. Let's say GPT 5.1, right? This is an LLM, large language model from OpenAI, and it is trained with some like training data set by these OpenAI folks, correct? And the thing is like they will suggest you anything which is there in their knowledge base, right? You can call this thing as knowledge base or something, right? Or yeah, training data set you can call TDS. Okay, this is training data set, right? But let's say you have your, like as I talked about our agentic application that we are going to build, right? So we are having application that are running on Kubernetes, correct? And there is, information is there about the deployments, pods, and our application. So right now, like this LLM doesn't know about this stuff, correct? So like, but LLM knows about explain me Python. If you ask explain Python, it will go do a semantic search and comes up with a new content, or the closest match, or it is like going to give you an answer, right? It will give you the definition. But if you tell this guy that I am having one microservice, right? I am having one microservice. You are going to tell this guy, can you please debug this microservice? LLM will hallucinate, or it will give you incorrect answer, because it is again going to search in their database. I mean, it is going to again search again its own thing, correct? What like LLM knows about. So right now it doesn't knows about your microservice, right? So it is going to give you an answer for sure, but that answer will be incorrect, factually incorrect, or it could be like it can hallucinate as well. It will give you some gibberish. So the thing is, there is a problem, right? That we have to somehow pass our context to this brain or LLM, right? So, so that's how you are going to use some sort of tools and mechanisms. There is some thing called as RAG, Retrieval Augmented Generation. That's how you pass the documents, right, to the LLM. So basically, whenever you want to give your custom context to LLM and you want your answer or response from the like LLM in a specific format, that's what is called as agentic AI, right? So here you can create agent, right? Like as simple as EKS diagnostic agent that we are going to build. So it is capable of debugging your cluster, right? I mean, it is capable of debugging application running in your EKS cluster, or let's say in a Minikube cluster, or a K3s like cluster, right? So this is what becomes an agentic app. This together becomes an agentic app. Okay, so this is going to is going to solve your problem of diagnosing an EKS cluster or any Minikube cluster, right? So this is what differentiates between like Gen AI and agentic AI, right? So build AI agent that reason, use tools, and take actions autonomously. Okay, here what action we are going to take? We are just debugging the Kubernetes application, correct? So yeah, then another thing is, oh yes, Shivansh.
Yeah, hi Sankalp. So just curious to know like how we are gonna set the rules for this LLM so that it won't hallucinate. I mean, are we setting any payload for this or fine tuning? Like how we are going to set the rules?
Okay, okay, great question. So we are going to use the guardrails. So there are two things. One thing is like in the prompt, we are going to set up that what is going to be the input, and what sort of, let's say you can just say you are a Kubernetes expert and you should like take in the queries related to Kubernetes. So we can add those things in the system prompt to basically out of this vectors, you can just, narrow the content down, right? Like you ask the LLM to think in that direction. So that is how you are going to make it behave in a certain way, right? For your specific use case. And another thing is you are going to have guardrails in place. So whatever output it gives, right, whatever output it generates, you you just check against the guardrails. And there is something called as LLM as a judge, which you can do using another LLM, where you specify like how the answer format should looks like, right? Because let's say if you are going to diagnose, you are going to create an agentic application for diagnosing Kubernetes. So the blast radius, or the surface area reduces to specific Kubernetes domain, right? So that's where you define all those guardrails in there is a tool, something called as like Langfuse. Okay, you can define those guardrails, and you can use another LLM. Let's say if your application is using Sonnet 4.6, right? If your agentic application is built on top of Sonnet 4.6, you can use, let's say, Sonnet 4.5 as a judge, right? Where the output from your application is first going to go to the Langfuse, where this another model is connected, and this has like sort of questions, or sort of question answers, sort of a database where it judges the output of your agentic app, right? So that's how you verify and validate your response of this LLM. Yeah.
So
Yes,
Sankalp,
Ivansh.
how many LLM calls will be there? I mean, if we are, if we are using Sonnet 4.6 and then again we are cross-checking with Sonnet 4.5, so the LLM calls will be increased, right? I mean, can we
Yeah.
use few shots as well? Like if we are confident for our answer, then we can have a few shots for the cross configurations. What do you think?
Sorry, Shivansh, can you come again? Yeah, I know that this calls are going to increase for sure. Yeah, what was your last question?
So can we use a few shots as well so that might be it won't hallucinate further? Because
Yes,
if
yes.
you're cross-checking with Sonnet 4.6 and then again Sonnet 4.5, so might be the LLM calls will be much, right?
Yes. That are going to reduce. Yeah. Again, you can have some sort of like in that case, you can have your vector DB or right, and you
Mhm.
can cache some of the result, and then you can use the similarity search and things like that
Mhm.
to determine the accuracy of that. So that can be the another way to
Oh,
reduce the LLM cost. Yeah.
yeah,
I hope
got it.
that answers, right?
Yes, thank you.
Okay. Uh, yeah, Naveen.
Hi, Sankalp. So I see like this model can be used everywhere, right? It's not only going to be on Kubernetes application. We can use it for any DevOps project. Is that
Any
correct?
DevOps project. Yes. For example,
With,
let's say right. Yeah. Go ahead. Sorry.
yeah, good. For example,
Yeah.
like I mean, with any
Hmm.
project with we are not using Kubernetes. Well, we have only CI/CD pipeline without a Kubernetes.
Yes,
Okay.
exactly. That's where I was going to. Yeah. So let's say you have a Jenkins, right? So as a CI/CD platform, and you are running a lot of builds, right? And one builds fail. So yeah, let's say you want to create a auto triage bot or auto triage agent that first triages the build, the failed build. So you can use there as well. So you have to just like let's say if you're using MCP, so you can use Jenkins MCP, something like that, to connect with your another application. So yeah, Ram Sundar, I can see you have raised your hand. So
Yeah, like I have a question so we can also go for a logs basically. We Kubernetes, we also have the pod logs where we can check the logs actually.
logs, yes.
Why we need an agentic AI over here since like it's just debugging and it's just telling us and telling what's the issue is. So we can go for a logs and we can get it correct.
Yeah. Of course, yeah. Right. I mean, the thing is, we everybody has this on-call model and stuff, right? There are engineers, so who get a page first, if just in case if it's a P0 or P1, right? So of course we can just go and check the logs, but the bootcamp is mostly oriented towards a building and just how to build an agentic AI application, right? And solve a real use case problem. In your case, I totally agree, right? You can go and check the logs, right? But that checking the log is going to take some time, right? So agentic application can just reduce some of the minutes, right? It might make not like it may not make sense right now, but the thing is, let's say you are going to create your own chatbot application, right? Where like let's say you own a company, and then there are a lot of user queries that are coming in, correct? Regarding some fact or something like that. So you want to let's say you own a product, you are a security company, and somebody goes and asks whether you support endpoint security, something like that, right? So in that case, you can have your like all the supported functionalities in the database, and then you can have an LLM to which you like give this data through a RAG, and then it is capable of answering the questions to the support, right? So this is like a more productive use case of such LLM agentic application, right?
Yeah.
Does it make sense? Yeah.
Yes.
So
And
right.
if
Hmm.
sorry to interrupt you. So is this like will just give us the suggestion or what was the issue, or it will give us suggestion how to handle it or
Yeah,
something?
it will tell us what is the issue, and it will give the suggestion as well. So yeah. Yes, Ivansh.
Yeah, I think for Ram Sundar, I think I know the answer what he's trying to tell. So basically, with that application, we can further use in the logger as well, right? It's just like we will just change the set of rules. So instead of debugging the Kubernetes issue, we can have some logger issue rules like for the P0, P1, and further with the logs, AI can able to handle the cases, right? Sankalp, if
Correct.
I'm not.
Yep, that's correct. Yeah. It's just the way like what you want to do with it, right? So I just try to take a simple example. So just to make sure that everyone is able to write their own agentic application and solve their own use case, right? Yeah,
I
it can
was
be
just
just
thinking like
replicated.
so that like
Yeah.
we are using it, correct? So how can I use it? So so that's why the question.
Okay.
Yeah.
Okay. No, no worries. Like you, I hope you got your answer right
Yeah.
now.
Thank you.
Okay. Cool. Cool. So then we are going to check on the observability part of it, right? That the thing is, observability is really, really important, right? So once you create your software, right? Okay, just yeah. Once you create your software, right? Any application, and let's say you deploy it onto some platform, let's say EKS, right? So here your application is running, and if something goes wrong in the production, right? And if you don't have any observability, it's just like a black box for you, right? So observability is really important everywhere, as everyone might be knowing over here, right? So the thing is, like, again, we need an observability on the LLM, right? So right now we are creating this Drishti, right? And it is going to call LLM model, right? So what happens to this call? How much token got consumed, right? What is the cost for every call? So that that needs a trace, right? So that has to be traced. So we are going to make use of something called as Langfuse. So whatever call we make, we are going to send the traces onto the Langfuse, right? So it will give you, different different functionalities. So one is the traceability, right? You can trace the request. And then another thing is like what I just discussed, LLM as a judge, right? So again, it will need a cost. That is different thing. We can optimize on cost, but I'm talking about the future. Like I sorry, not future, like feature. And then another thing is you can mostly create budget and all those things. You can check on the cost side as well. So yeah, so let's say multiple teams are using it, so you can enforce some sort of budget and stuff. That okay, so this is the maximum budget allowed for this team to do our investigation. I mean, to do their investigation, or that's the number of times like they few folks can call this drishti, right? So that thing we are going to see. Uh, and yeah, and then production packaging is just another thing, right? Like shipping, how you are going to create container through Docker and then deploy onto Kubernetes. So we are going to start with the basic Python stuff that is specific to writing this agentic application. We are going to see different things like how LLM works, and we will make use of these libraries and frameworks such as this LangChain and LangGraph. So that is how you are going to write, talk to your LLM and create agentic application. We are going to use Kubernetes. We running on Minikube. So we are going to deploy a broken application, and probably we are going to deploy this agentic application as well onto the Kubernetes, and then we'll talk about some of the Kubernetes concepts as well. So I got a feedback that there are a few folks who didn't got a chance to work on Kubernetes. So I'll be taking this as well. And then we are going to see MCP, White, KM, and you know what things it solves and things like that. And Docker, Helm, Lanxess I already talked about. So yeah. So now let's answer this. Who is this for? So any software engineer or DevOps engineer who wants to get into AI and who want to just create agentic application and solve their own specific use case. So they will have full idea how they can write their first agentic application. And then yeah, this is something which is common, that everyone will get to know about the foundation aspects of the Kubernetes. And yeah, so this is most important thing, which I feel that every company needs an engineer who is expert in using right tools to solve their use cases, right? So you can just flaunt this project in your resume, because you will be knowing in and out of it, what use case it solves, and yeah, it is going to give you a good impression, and it will help you to land. I mean, it will enhance your resume, and who knows, you land a new job, right? New fancy job in certain org. So that is the thing, because you know all the agentic AI stuff, right? So yeah. So I think that pretty much gives the overview. Until and unless anyone has any doubt, can we proceed further?
Uh,
Uh,
Hi, Sankalp. This is Mayur.
yeah. Hey.
So, Sankalp, currently I'm working in automation, UiPath automation, and I have seen agentic AI in that as well. UiPath plus
Okay.
agentic AI. So, how this will be, related to that automation agentic AI? So, is this worth it?
Yeah. So what sort of automation you do? Uh,
So it's a like a, total end-to-end automation, creating a workflow on your Apache Studio. So there is a different RPA, means you can say the RPA domain, and I'm working on a UiPath tool. So there is a
okay.
agentic AI also, now the new feature come in that tool. So that's why, is this related? Is this will be helpful for that?
Yeah. Of course. Like I assume that like. Everyone makes a transition, right? One or the another day or month or year, right?
Yeah. Yeah.
So right now you are working on UI path, right? So UI
Correct.
path, as I know, like I know a brief about it. So
Mhm.
like so it's like sort of, yeah, RPA, robotic process automation stuff, right?
Correct. Correct.
Yeah, but the thing is, like they are using, like they are having their own workflow, right? So it's
Correct. Correct.
like once let's say you make a transition to another company, so they might not be using the same things or the same workflow, right? The process
Yes.
might be different, right?
Yeah.
So yeah, so their workflows could be written in some different tool, and they might be having their own operational challenges and some of these triaging challenges. So if you
Okay.
have this knowledge, so of
Mhm.
it is not going to like I mean, it will give you another strength to or another area or
Mhm.
yeah, another area to think on. And
Okay.
definitely, like you can leverage the same workflow, because that's how, I mean, pretty much the standard which most of the company follows, right? Even though, like, if it is automation, there will be something,
Correct.
some use case that is still not solved, right? Your company
Correct.
hasn't
Correct.
solved, or they are trying to solve.
Yes.
Yeah,
Yes. Yes.
because the thing is, automation is going to, like it has already. I can already see that every company is one or the other day just releasing other tools and
Yes.
reducing
Yes.
some sort of headcount. So the thing is, we have to either start
Right.
using
Right.
AI to the fullest to
Mhm.
cope up with the change, right? So that's the
Mhm.
intention. So definitely, like I can check on your particular thing.
Yeah. Please. Thank you.
Mayur, we can connect after this call over this, okay?
Yeah. Sure. Sure. Sure.
Hello. Sorry, guys. Like, I got dropped off. I mean, yeah. Am I audible?
Yes, Sankalp.
Yes,
Yeah.
Sankalp. Yeah.
Yes. Oh, yeah, yeah. I was answering something. Yeah. Like, I'll we can check. Like, we can talk later on that. Okay, for your
Yeah. Sure.
thing.
Sure. 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 Sure.
Don't mind. Yeah, yeah.
Yeah. Yeah. Sure. Sure.
So,
No worries.
yeah, yeah. Yeah. I like. There was another person who has a question, I believe, right?
Yeah, Shankar, Shubham this side.
Oh, yeah,
So,
Shubham. Yeah. Hmm.
yeah. So, uh, so if a pod goes under a various state like crash loop backup or image pull backup or a pending
Mm-hmm.
state, so this kind of uh, issues, agentic AI will right away analyze, and right away the pod will be going under running state. Is that we are going to implement, or it will just inform us that pod is going under this state, and we need to we they will provide us these solutions. How we are going to?
Yeah, yeah.
Yeah.
So yeah, as I said, like we are going to build diagnostic agent.
Okay.
So it will be able to flag the issue, right? If a
Mm-hmm.
pod goes in a crash loop back off, right? So
Mm-hmm.
it is going to tell you, okay, so this pod is going on this crash loop back, okay, state, or let's say ohm killed state. So then it is let's assume, okay, the pod is crashing because of ohm killed, right, out of memory.
Okay.
So it is going to tell that this is the current memory, right? This is the request, this is the limit, right?
Mm-hmm.
And looks like request is like exceeding the limit that we have set, and that's why it is failing. So it's possible, like and then it is going to suggest you probable solution. Okay, you can either increase the limit or something like that, right, based on the context of the
Okay.
application. So but the thing is, it is just diagnosing it, right?
Okay.
Because I
Okay.
never like suggest folks to do that, like apply the changes in the
Uh-huh.
infrastructure
Uh-huh.
specifically, right?
Right.
Because I've seen, like, there was another company, pocket something, pocket book or something
Pocket
is there,
OS.
like, so Pocket OS, yeah,
Pocket
exactly. Yeah, thanks, Tanisha. Yeah. So like these folks are doing some sort of like LLM based debugging, and they're just applying the changes blindly. And the thing
Mm-hmm.
is, the impact was it deleted their own database, and it was irrecoverable. So the thing is, all
Uh-huh.
the snapshot, DB snapshot, the entire shit got deleted. So
Okay.
so I never suggest, like, for I mean, right now we are not in that stage that, okay, it can just
Okay.
take that, like, implementation or infrastructure changes
Mm-hmm.
by its own. So that's why I just said diagnostic agent, right? It
Okay.
may not be really useful, because you will say, okay, I can debug on my own, right? Why I require this agent, right? But that's not what the class is all about. It is
Yes.
about, right, creating an agentic application. You
Mhm.
may be having different use case to solve. You can go and build
Okay.
your own, right? But you should know the meats and potatoes, or the nuts and bolts of it, right? How we
Yes.
are going
Yes.
to build it. That's the
Yes.
intention, right? I hope it clarifies it, right?
Yes.
So
Thanks. Good.
okay, yeah, no worries. Yeah, Ram Sundar.
So, are we going to use Claude and stuff like what will be the tools which we will be using?
I think I am going to, like, for this one at least, I am going to go ahead with um, GPT or something. Right now, I haven't decided. Reason being, I am looking for some free subscription and stuff, so we can use any of the LLM. But yeah, like, if you want to do your POC, you can use Claude or something if you have the subscription. So yeah, like, on the model, like, again, it's just like you just change it on the go. No impact or no issues. I mean, if you use the highest model or the latest model, it is going to give you more accurate answers. So that's never a problem. But right now, I haven't decided. Let's uncover this in the subsequent classes, right? And let me
Sure.
figure out. Okay.
We can use Grok. It's free.
Oh yeah. That's a great suggestion. So we can use that. I'll check on that. Yeah. Okay. Thanks, Shivansh. Okay. Cool. Yeah. So the thing is, like, why I don't know, because I'm using premium models. Like, I use all the my company tools and stuff. So I never checked in this direction. So forgive me for that. Okay. Uh, so we are ready for the next leap, right? I'll take it as a yes, no questions, right? So let's talk about, let's little bit talk about the transition that has happened, right? Since we are dealing with AI, agentic AI and DevOps, right? So I just wanted to tell you briskly, like, how the things were before and how the transition has happened, right? Something like that. It's just a story, right? That I always used to teach. I mean, tell my students. So the thing is, like, change is the new normal, right? Change is the new normal. in COVID, right? So remote opportunities bombarded, right? So nobody used to like give remote jobs earlier. I mean, they were very less, but it like that changed the entire corporate culture, right? So we came from 5 days a week to 3 days to days a week, and some to fully remote, right? So change is the new normal, right? So the thing is, let's go back to 2000 or something, right? So when there was no cloud, right? And then when there was, like, at that time also we used to have application, right? So we used to have this software, right? You just write some piece of code which is ready to be shipped, right? And you found some $1 billion idea back in 2000, and you want to productize it, right? Or productionize it, right? What you are going to do? What are your options? So earlier there was a rack, you can say, which contains servers, right? A rack contains, it can contain one servers, or group of servers, right? Which are nothing but some host. I mean, which are nothing but just some compute, right? Compute with some bandwidth attached so that it is connected to internet. It runs on dual power. It runs on dual network cards. It runs on everything, dualize probably, right? So just to make sure that they are up 24/7, right? So let's say you have a server of 4 CPU and then 16 GB RAM, right? And this is again 4 CPU, 16 GB RAM, right? So the thing is, what you used to do earlier, right? Earlier in the servers, you used to install host operating system, which is pretty much the Linux flavored, right? Linux flavored operating system for running any application, correct? Again, why Linux? The thing is, like, it is not like it's just a general. Like, the thing is, you can just use this. Like, you can opt in or opt out to have a UI, and opt out of the UI and just have the bare minimum features running, right? And the architecture and all those things, right? That everyone appreciates. So they, everyone runs their servers on Linux, right? And again, entire thing is there, like you can check on those separately, right? Why Linux and why not Windows? So that is something. And so Linux is the preferred way of running all this application because of like a lot of different cool things that you can do. And earlier, you have this server, and then you have any operating system. Let's say we can say right now host OS, and then you run your application, right? The thing is, like, the earlier challenge was uh, the earlier challenge was how to keep this thing up and running, right? That is one thing. You have to have like huge power supply backups and things like that. You have to run your own infrastructure. And then another thing is, like, you don't know how much servers are required, right? Whether it is one, whether it is 1,000, whether it is 500, and at what time how much servers is required, right? So it servers, like, if you buy a server, if you run your application, it will always incur some cost. The cost is constant, correct? The cost is constant, right? So let's say if you have this application, and let's say only 100 hits are coming in this application. So and this server is capable of taking, let's say, 1,000 hits. Okay, 1,000 hits, let's say, per minute or whatever, right? So I'm just throwing some arbitrary number. So yeah, the thing is, so this application is sort of like, this server is sort of an overkill, right? I mean, we are not utilizing it to the fullest, right? That's when the transition happened, and then something called as virtualization came into existence. Okay, then we have something called as hypervisor, right? So hypervisor basically uh, sits on top of your physical hardware and just interact with your host OS, right? So it's sort of a medium, and it allows you to run multiple operating systems. Okay, so then came virtualization, right? So it looks something like that. Like, now what do? You run a physical server. So let's say this is a physical server, right? And then there is physical hardware, right? On top of physical hardware, we have uh, mostly like what? Host OS, correct? We have host OS, and then we have this hypervisor, and then we have some guest OS, another guest OS, and inside the guest OS, you used to run your application, you used to give the dependency, right? So this is what the scenario back then. So, so the thing is, this host OS makes use of kernel, and this guest OS makes use of another kernel, right? So kernel, what is kernel? So it's nothing but the heart of the operating system, right? That interacts with the like physical hardware and get your job done, right? And like whatever commands you give, it just executes it, right? And it makes use of resources and stuff. So if you see, like hypervisor was the one which is bridging the gap, right? Of like deploying multiple guest OSs and using the same physical hardware, right? So this is one of the like most efficient way back then to run your application and effectively utilize your hardware, right? So basically, the kernel was not shared, right? The kernel was not shared. So every OS gets its own kernel because, like, yeah, everybody creates their like every like most of the. For example, Windows kernel is different and this Linux kernel is different. You can't run Windows on Linux directly, so because they don't have like similar kernel thing, right? So I'll talk about that in Docker. So that is one issue. Then you have to do some of the other things. So then you can like run it. So that's a different thing. Yeah. So this was like how then virtualization came into picture. So in a similar server, in the same server, you run two different application or two Linux. You can run two Linux instances where your application is running. So you are sort of like let's say you're running two applications now, or two instances of the same application now in the same server, right? So that was back then. So the thing is, like, the problem here was key the resources were not utilized to the fullest still, because guest OS against take a huge amount of space, right? Because at that time there was nothing like run a simple Python image in Docker, right? So there was like, let's say, Linux flavors of Linux out there. Then you can install as a guest OS, run your application. It comes with fully fledged tools, right? It contains VI, it contains Emacs, it contains all the networking aspects, all the file system aspects, all the entire thing was packed in the guest OS, right? Or any other OS. So that there was like a lot of unnecessary things that are coming in, which was not required at all, just for the sake of running your application, right? So this is yeah. So the caveat of this was the image size of this VM becomes huge. Okay, so let's say at that time, like, there was an option also for to create VM images as well, right? So you can create VM image, you can replicate it onto different server. But the thing is, like, the kernel is separate for the underlying OS, and there are a lot of unnecessary things that are again present, which are not required at all. Then came Docker. Then came Docker, right? So how this thing has changed is, again, we have physical server or physical, oops. Again, we have physical hardware, right? And on top of that, you have a host operating system, right? Let's say we are using Linux, right? All of us mostly uses Linux, right? Who are doing software development. And then there comes another magic thing, which is Docker container runtime. Okay. And on top of this, you used to run containers, another container, another container, right? So now what's the magic is like, again, it is an operating system, it will have a kernel, right? So the kernel is shared, like, by all the containers, and the image size was drastically reduced. Okay. If you want to run a smallest image, you can run Alpine image, which is again a OS on its own, a small OS on its own. I think it's less than 5 MB or something. I'm not sure. So you can run a OS that is small as like 5 MB, right? And you can like, it doesn't contains anything. I mean, it is having like bare minimum features, right, that are just required to run an operating system, and then you can add all the things that is needed, right? So it was that smart. So the thing is like this, with the help of this Docker container runtime, you can effectively utilize the resources, underlying resources of any node or hardware, right? Or let's say you can say server, or it can be a node, whatever you want to call. Correct? So that's how the transition happened, the pivot happened, and it solves the resource, like it solves the problem of effectively utilizing the resources. That was one problem. And you might have seen the meme, it works on my machine, right? This was a classical problem back then. Ki folks who have, I mean, the software engineers who have just created an application, right? It works on their machine, but when they ship the application onto the production, it doesn't work over there. Why? There is some dependency version mismatch, or some of the dependency is not added to the image, right? So it solves problem. It gives a unified environment, right? Unified environment to run any software application that you are going to build, right? Or you're building. So whatever application you build on your machine, you log the dependency, you create a Docker file, one image will be created, and that same image with all the packed dependencies are going to run in the another system, or it can be your friend's machine, it can be your servers, or it can be anywhere, right? Any hardware, which supports Docker, of course. So yeah, so this was another cool thing that we solved using Docker. Now again the problem came, right? So let's say if you let's say you run a Docker container, right? You run a container. This container, let's say, is capable of handling 10 requests. Okay. So the thing is, this is fine, right? This is fine. You run it in one physical server. And let's say one physical server is capable of handling total 20 requests, right? Assuming it again depends on the CPU utilization and memory utilization. That's a different thing. But let's say in ideal case, it can just handle 20 requests based on the nature of your application. One container handles 10 requests, right? So what you can do, another container you can run. So at any cost, you can run 2 containers at max, right? Because they together then can handle 10 requests, right? And then 20 is the total, right? So you can manage one node, right? Let's say if this container crashes, you can go and manage one node. Let's say you scale it up 2 nodes, right? You added 2 nodes, right? Another 2 containers you have added, right? So now this can again handle 20 requests, right? So as the scale is increasing, as more load is coming, you keep on adding more nodes, right? Okay. You keep on adding more nodes. You can handle 5 nodes, okay? But you can't handle 5,000 nodes, right? If your application is running at that scale, you can't debug which container crashed, which why my application went down, which node is having issue, which node is hitting memory and CPU is throttling, right? all those kind of management, or in music we say orchestrator, right? So we want something to orchestrate the containers that are running in the node. Okay, so that's where we like this Kubernetes came. So Kubernetes is the one that orchestrate your containers that are nothing but your like application instances, right? So that's how the transition happened, right? So earlier we used to run things on the bare metal servers. We own servers, we manage them, and then we add more servers. We take care of the dual things like dual power supply, dual card, just to make sure everything is highly available, right? And we can run 24/7, making sure none of the server went down, right? Then resources were not effectively utilized. Then came virtualization, which gives you which gave you the power to have host OS and multiple guest OS, right? So at that time it was new technology, right? And then we used to run applications, multiple instances of the same application through the VM image. We scale the image, and that's how we effectively utilize the entire server rather than just running one instance of the application, right? And then we see a problem. Okay, there was some kernel is sort of like duplicated, or every OS requires its own kernel, and there is like a lot of different additional things that are coming up. Then that's when Docker was introduced. So this technology is called containerization, and Docker is the tool to run containers, right? So it just solves using Docker container runtime what it creates. So it just runs it like the container which is running on top of Docker container runtime shares the kernel of the underlying hardware, and you can have one of the tiny like smallest image, smallest running container, right? Yeah, with zero to, I mean, with least dependency, right? So that's how things is scaled. And then now we used to run containers instead of VMs, right? Like this virtual machines. So yeah, now we are running containers on different nodes. So the thing is, as soon as we scale it to 5,000 or more than 10 nodes, right? It becomes a bizarre headache, right? How do we manage them, right? And how do we make sure all the routing and every aspects of it is working just fine? That's when orchestrator was introduced, and Kubernetes was became like, there were a lot of, I mean, Docker Swarm is another orchestrator, you can say, to orchestrate the containers. But Kubernetes is the one which was created by Google and later donated to CNCF, and now everyone has adopted to Kubernetes. And then we have different flavor of managed Kubernetes came into existence: EKS, Azure, I mean AKS or GKE, right? So all of these are the different managed version of Kubernetes. So managing Kubernetes is another headache. Okay, so that's why we like all of these clouds uh, came into existence, and and this EKS and all those services came, right? So yeah, again, one thing I forgot to tell you, that yeah, all of these things earlier used to happen on premise, right? Which is nothing but you buying yourself and setting up your infrastructure, and then later moved on to the cloud, which becomes pay as you go model, right? So whatever requests come based on the usage, you are charged for different services. So I hope that is pretty much known to everyone, right? So yeah, that was sort of the journey, right? I just wanted to tell you in context of the DevOps, right? So again, it's not totally DevOps. So it is more like what are the key things that got covered, right? Now, if you want to see the DevOps, right, I can talk about that as well. So you might have seen something called as Infinity, right? So this is very pretty common in the DevOps domain. So basically, it's nothing but like build, test, deploy, right? Build, test, and deploy, and then back is sort of like, again, cycle goes back, right? So it is start with the software, like software engineer writing a build, like software engineer writing a software, writing like, and then doing the build, right? Gradle build, Maven build, whatever, right? Through Bazel, yeah, do the build, write the test cases, test it out, do some unit testing, do some end-to-end testing, integration test, run some integration test, and once everything passes as per your expectation, you deploy, right? If like once you deploy, things may work, things might fail that need hot fixes and thing. So again, cycle goes back, right? So this is a normal like sort of like SDLC cycle, right? That you generally follow. So earlier, what used to happen? We used to have two different teams. We used to have team of software engineers. We used to have team of operations. Okay, the job of software engineers was to just write the softwares, get the UT, the test written, make sure the feature is valid and it's working as expected and whatnot, right? And then operation team was separate team earlier back then who used to manage the on-prem infrastructure. Okay, so generally operation team used to handle all the deployments onto the servers, right? There was no Jenkins and all those kind of stuff back then, right? So it was like sort of manual scripts. It was like a lot of Ansible that you used to do, right? To make sure you manage the softwares, you install physical servers, you take out physical servers if something is off on them, right? So all those shit were there, right? So entire thing was managed by operations team. Okay, you can just say ops team, right? So what happened was like software engineer, let's say, write a software in one sprint, or let's say in 10 days, they write a software and they then submit a ticket to the operation team to get their deployment done to so that they can go live with the new release, right? Then the ops team takes some time, right? Depending on their, like, it's not like only one team is there. There are a lot of software development teams are there. Everybody is shipping some of their thing in their application that own. So ops teams are bombarded with a lot of deployment requests, right? So there is a delay. Correct. So there's a delay. So let's say ops team says that, okay, we are going to prioritize in next sprint, right? So 10 days you have worked, and let's say in the next 10 days, let's say in the seventh day they took, right? So there is a gap, right? There is a gap, like the gap of, let's say, a week, right? So the thing is, your software was ready 1 week back, but it got shipped in the seventh day, right? After like you stopped writing the code, once you pushed the thing onto, let's say, version control or whatever, right? So there was a gap. So there was a delay. You like engineers are not getting instant feedbacks, right? So the thing is, the moment they write software, they weren't capable of making it live with the click of a button. So that was the problem. So that's how, when like so that was one problem. Then eventually we moved on to cloud, right? A lot of things came, a lot of managed services has come, right? Now the thing is, we have different tools to tackle different parts of it, right? And create end-to-end automation workflow. So DevOps was one practice that suggests like how we can effectively ship software, and we have like a lot of this different build aspect, test aspect, deployment aspect of things automated, and a quicker feedback to the developers, right? So that's how this, like you can see some infinity circle once you Google it. So you'll able to see that there is something called as build phase, which is mostly like done. You can do it by either with the help of, like, you can automate this thing through Jenkins, and then some Bazel, Maven, Gradle, right? You can write a pipeline in Jenkins with all those things, all of these tools in place to automate this workflow. And then again, test, you can use same Jenkins and stuff with the help of your testing frameworks that you are using in, right, for writing the test. And then for deploy, if it is EKS is, let's say, is the compute, then you can make use of Helm chart, again one pipeline in Jenkins, or let's say in some other build kite, whatever CI/CD tool you choose. you write all of these automation stages, right? And once deploy, like you can control the environments. Let's say you are deploying in more than one environment. Let's say you have separate dev cluster, separate test cluster, separate production clusters, right? Which we generally have. So you can control in which cluster you want to send your changes to, right? And then like once you click, right? Let's say a software engineer commits a code to the main branch, right? Then this entire cycle triggers, and within few minutes or few hours, depending on the complexity of your application, you get an instant feedback, right? Okay, so either deployment passed or deployment is live onto the dev cluster, test cluster, or production. And yeah, there is no need of ops team, but there is a need of DevOps team. Okay, so ops team used to manage all the deployments earlier. Now including the server and all those on-premise rack installation with the help of IT team. Now we have DevOps team who takes care of the infrastructure through different tools. Let's say Terraform for managing the infrastructure in cloud through code, the Jenkins pipeline, like GitHub runners, right? And then what else? Then the Kubernetes, right? So like they should plan, like then the cost optimization thing came into picture, right? Now every workload is running, you want to minimize the cost of running your workload. So all of things were become a part of DevOps practice. So this entire thing is basically DevOps. I hope this like till now nobody is having any question, right? Okay, I'll take it as a what? No, no questions. Okay, cool. So yeah, I just wanted to talk about this because I just wanted to make sure that everyone is in the same pace. So yeah, because I don't want anyone to be left behind because I pretty much don't really know like who has worked in what all depth and who has got opportunity to work on the cloud aspects, or and someone who is just writing software since I mean, yeah, like 5 years, 7 years, any year. Yeah. So yeah, I hope this clarifies what the DevOps is, right? And so right now we got to know that what we are going to build, what is the use of it, who are the target audience, and am I doing the right thing, right? Joining this boot camp, is it worth is investing the time and money and blood and energy, whatever, right? So yeah, it is, because agentic AI is the need of the hour. So yeah, like there is a saying that peoples are getting replaced, like if you don't know that like if you don't join the force of using AI, like there are high chances that you are going to be replaced. So that is what, like, we are here to make sure that everyone knows which AI to use and how to use it, how to solve a specific use case that enterprise is tackling these days, right? So yeah, and on the agentic AI, I guess I have already talked about Gen AI and this agentic AI tools and observability stuff, right? I just don't want to I just don't want to waste time in redundantly explaining it. So what I got to know from Shubham that that, like, yeah, few folks are new over here and they would like to know about Kubernetes core concepts, right? So I have included that as well in my bootcamp. So it may, like, the bootcamp may extend by 2 or 4 more classes. So I believe everyone is fine with it, right? Okay, cool. Yeah, yeah. So which means that you guys are going to learn about. Okay, you guys are going to learn about Docker complete picture, I would say, and then Kubernetes. Mostly that is required by a decent, I mean, someone who can just ship anything to Kubernetes till that domain, right? I will not say that you will be able to fully manage Kubernetes, but one thing that I can surely tell you that you will know how Kubernetes things are structured internally, how the connectivity is happening, how we are going to deploy the application, and how you can deploy your application. That is the least which I can guarantee. And again, there is always cherry on top, which you can just, you can always refine your language in reading further, or just reach out to me. We can have a casual talk, something like that, and then discuss some of those things. So that is, those are two things. Another thing is Drishti, so which is like, again, your agentic stuff, all the meats and potatoes you will learn. Okay, so this is how you are going to create your agent, so which we have already discussed in depth. So let's not waste further time and dive on the Docker 101, or the fundamentals of Docker, right? So yeah, excuse me, I'm feeling a bit thirsty here. So so by the way, guys, you need a 5-minute break or something?
Yes.
Yeah, sure.
Oh, okay, cool. Then let's meet at 12:27. Okay, I'll resume at 12:27. Yeah, cool. Hello, guys.
Yeah, yes, Uncle.
Cool. Let's wait for another minute. Cool. I think we can get started and get back to speed. So, yeah, just a quick thumbs up for me, just to see like how many folks are back. Okay. Nice. I can see plenty of them. Okay, cool. Let's get started. So, moving on to fundamentals, Docker 101, right? So, what is Docker and why we use it? So, pretty much, I have given you an idea why, like, what is Docker, right? It's a containerization platform that packages your app and its dependency into a single portable unit called container, right? So, why do we use it? It is just to package your app and dependency into a single portable unit. Portable is important, right? This is what I have already explained 30 minutes back, right? It's a containerization platform. And earlier we used to have virtualization, right? We used to do virtualization. So there was one tool called as VirtualBox, Oracle VirtualBox. So that was the tool. And then, yeah, through which we used to do the virtualization, right? Which means installing multiple guest OS, correct? And here we are talking about containerization, which means like running multiple portable units called container, right? So this is done. The problem it solves, it works on my machine, said every developer like ever. So till the time when Docker was not around, so this used to be the scenario, right? And I'm pretty sure that everyone must have watched memes around it, right? In Instagram or whatever. So yeah, that generally used to happen when there was a version mismatch, missing system packages, different pip dependency, which resulted in broken environments. And so Docker ensure consistency across dev, staging, production, as well as your laptops. I mean, if you writing code, gives to someone else, make sure Docker makes sure that dependency is or the environment is unified. VM versus container, full operating system per app, shares host kernel. We already talked about it. Size of the VM images were pretty huge. When I say huge, so it means 10 GB, 10 GB to 50 GB to 100 GBs, right? Depending on the underlying OS you are using, plus the complexity of your application, the binary files. I mean, the build, all the intermediate build artifacts, whatever your file is creating or whatever your application is creating. It depends on that. So size was pretty high. Size is in MBs, right? It was slow to start, right? Why? Because again, the image is huge, right? It will take some time to boot and fast to start in seconds. So you can run a single OS within few seconds. It's heavyweight, it's lightweight. Okay, that's fine, right? Everyone knows about it. Docker architecture. How the Docker architecture internally is laid up. What are the key components, right? Docker follows a client server architecture, simple, normal, like one of the most simplest architecture in the internet era, right? Understanding how the pieces fit together helps you to debug and use Docker more effectively. We have already talked about it, right? So Docker daemon. Docker daemon is nothing but your like container runtime, right? Basically, yeah. So you have your Docker daemon, right? So Docker daemon is nothing but your like it provides a container runtime, right? So it has different functionalities. So this is more like your server, right? So like images, containers, volumes. So these are different constructs or different features that Docker offers. So Docker daemon is what we used to say like to the container runtime that is provided by like this basically Docker. And then we have this CLI on top, which is nothing but makes a call to this Docker daemon. So which is nothing but makes use of REST API, right? So something like that /create, right? All those kind of thing. All the CRUD operation is done through REST API, and then yeah, with the help of with the help of the CLI, you use the commands such as docker build, docker run, docker pull to perform some of the operations, right? Which we will see later, right? And then we use like so this container runtime basically takes the command through docker CLI, right? Processes the command. Let's say if the command is creating docker image, so like it just builds the image, and it can connect to any artifactory to store the image, right? One of the most popular artifactory is this Docker registry, right? Docker registry or Docker Hub. I guess Docker Hub is the name, right? Yeah, Docker Hub is public kind of artifactory for like checking the Docker images, right? You can just create an image, push it to it, and pull, and somebody else can pull it from there. And generally in corporate, if we are using AWS as the cloud, we generally use internal registries such as ECR. We may use GitHub GHCR. We may use JFrog artifactory, right? And then again, all of these different flavors have different additional functionalities, right? That they provide. So again, it's not necessary you have to always use ACR or like ECR or JFrog. It depends on the use case, right? What you want out of the artifacts that are stored in your artifact, right? Or registry. Again, key components we have already seen. Docker CLI, command line tool, which is used to interact. Docker daemon, the background service that does all the heavy lifting, builds, run, and manages images or containers, right? REST API is nothing but your interface between the CLI and the daemon. So container D is actual the low level runtime. It's the low level container runtime that actually starts and stop container. So basically, if you see like the server that you build for Docker, like that the Docker has built is a Docker daemon, right? Internally, it has this container runtime, which is nothing but container D. So what it does, container D actually creates the resources. You know, it talks to the kernel, right? And which in turn get the right amount of resources to run your container. So basically, Docker daemon is what we call as a container runtime, but internally it uses container D as a container runtime. So like recently in the recent Kubernetes version, the support for Docker or Docker daemon as a container runtime is like removed. So earlier when we used to run Kubernetes, so there we can configure this like Docker daemon as the container runtime to run the containers, right? Which internally again uses container D, okay, to create the container. But now the thing is, in the newer Kubernetes version, I guess after 1.28 or something. I'm not sure. I might be wrong over here, but I know this that right now the official container runtime supported by Kubernetes is Container D and not Docker D. So yeah, you can do the fact checking and stuff, but this is how this is what I know. And then yeah, Docker daemon, and then Container D is the low level runtime, and then registry is what the storage, right? You want to store your images somewhere. So how does a Docker run works under the hood? You type the command docker run fast API and then this. So the client sends the request to the Docker daemon via REST API. Daemon checks if image exists locally. If not, pulls the image from the registry. Daemon instruct container D to create a container. Okay, and then container D setup namespaces C groups. So yeah, what are these namespaces and C group? These are nothing but your Linux constructs or Linux functionalities. Yeah, so to make sure that you know your container is isolated, it creates a namespace. And like you can have so basically this container D creates separate namespaces for your each of the container to run. And then C group is basically limits like that you can assign to this namespace, which is nothing but your container in Docker term, right? So we specify a budget. Okay, you can just use one CPU or zero point 0.5 CPU out of 4 CPU, right? So those sort of limits are controlled via C groups. So yeah, so this is what under the hood happens, and then your fast API app starts inside the container. So basically you will get a container where your fast API application is running. Correct. This is your application. This is your container or Docker container, which is running in the server or let's say in your host machine. Correct, where Docker runtime is there, of course, right? Whenever I say server or host, that means we have a Docker runtime, which is nothing but Docker daemon, right? So we can run it on any machine where Docker daemon is running, and then it makes use of namespaces, C groups, which is nothing but low level Linux constructs, right? To like that tells us how to run a process in isolation, how to enforce that this is the limit that is specified to you to run the application, right? So basically you define a periphery or a proxy, like periphery is the right word, right? Parameter for any application to run, right? That you can't go beyond this, something like that. So yeah, Linux primitive. Yeah, okay. Oh, this is already written over here. Linux primitive Docker relies on namespaces, C groups, union file system, isolate processes, networking, file system per container, C group, limit CPU, memory, and IO resources per container, and then union file system stacks image layer efficiently. So basically, Docker makes use of different file system, which is copy on write. So this is what file system it internally uses to create the binaries or images. Okay. And containers are not VM. This is important. They are just isolated processes on your host machine made possible by Linux kernel feature. Again, yeah. What are these like primitives? These are nothing but features of the Linux kernel, right? Because see, Linux kernel is the only one who specifies and controls the hardware. So these are the features out of the box specified by the Linux kernel, right? So containers are not VM. This is clear, I guess. They are just isolated processes, which we call them container in fancy terms, right? In the Docker territory, correct? So yeah, core concepts. Your fast API code. So how you are going to run your Python code or fast API code onto a container or on Docker, right? So you write your API code, you create a file, something called as Docker file, right? Which is nothing but the instruction that you're going to give to the Docker, right? And then through the Docker file, you create an image out of it, right? Which is blueprint and it's read only. Okay. And then from the image, you can spin up a running instance of an image, which is nothing but container, right? I think easy so far, easy peasy. So key terms, image, a read-only template. You can think of like a class in object-oriented programming, right? So a read-only template. So you define in the class, let's say you define what are the data types, right? I mean, what are the like variables, and then you define functions, those kind of thing, right? Data member and member functions, basically. In OOPS, you decide. So you define, okay, this class contains only this thing, and this is what this class can do. It has these only method. So this is how you give instruction, or this is how you give instruction through Docker file and create an image out of it, and it can do only that particular task, which is how the image is like, which is what the image is cooked for, correct? And then container just it runs it. Docker file is like a script with instruction registry, again done. Layer, okay. So the thing is, as I said, that Docker makes use of separate file system, which is what? Copy on write. Okay. So basically, basically it makes you use of this copy on write file system, which is a sort of layered file system. So the thing is, every instruction creates a layer. Every instruction creates a layer, which is nothing but some contains the content of the file. Like you can think of as a hash kind of thing. And then different instruction creates different layers, right? And these layers get cached in the file system. And whenever you change command slightly, so the previous instructions are pulled from the cache, and only the newer one is built. So this is how the system of the Docker technically works. Each instruction in Docker file creates a cached layer. So yeah, so image, layers, and caching. Now let's see what are the slightly kind of starting directives in Docker and how the layer is created, something like that, right? So Docker builds images in layers, each run, copy, and add. So these three Docker instructions, or you can say Docker directive, creates a new layer. Okay, so whenever you give a command, let's say run, and then this app.py or whatever, right? App.py or run Python 3 and main.py. So this creates a new layer in the Docker. Okay, and if you give something called as add, and then you give some HTTP address and then put a dot, let's say, right? So add is a instruction that pulls file from a remote from remote URL, let's say, and then it can copy it to the your container. Okay, so yeah, and then copying from local host machine to the container. Okay, we will see all those things if in case just you are just overwhelmed. So yeah, so Docker builds images in layers. Each directive, each run, copy, and add creates a new layer. Layers are cached. Unchained layers aren't rebuilt. This is what I said. The layers which are not changing, they will be pulled as it is or used as it is, and only the new changes will be built, right? And then copy this before your source code. So okay, fine. So let's see the structure. So basically, this is your application. Let's say you have requirement.txt. Let's say you are using Python. So in the Python, we use this requirement.txt, which is nothing but a key value kind of file where you just specify request equal to 3.0, 1.0, whatever version it is, right? So it's a version to your dependency, right? And then you have main.py where you write some actual code with the help of the libraries, right, that you are using in the requirement.txt. And then you can have your, again, structure, like application structure. Let's say the application is complicated little bit, right? And it is just like sort of web application. You can have this routers, models, database.py to handle the like connection with the database and the models. You can have to have some sort of ORM mapping, right? Like data modeling kind of stuff that you do in the typical software engineering stuff. And then router is something you want to route it to specific microservices or something you want to do, right? You want to route the request based on some path parameter or something like that, right? So this is how your typical structure look like. And then along with that, you have a Docker file which contains instructions, right? That how you are going to build this thing onto the container, right? Basically, eventually container, but in the image first, right? So Docker file contains instruction to build an image. Then this image is pushed to registry, right? Registry. And then you can just, you can run this as a container in the server, correct? Which is running Docker daemon, Docker D, correct? And Docker ignore, Docker ignore, Docker ignore. It is again a special file that let's say that prevents some of the file changes to push onto the image, right? Let's say you don't want to push this particular chunk onto the Docker image, final Docker image, right? So you add that thing in the Docker ignore. So name suggests, right? Ignore. So it is ignoring something. In our case, something is the files and all those stuff, right? So yeah. So here is quick requirement.txt. You have different Python or the libraries defined. You have a smallest code to run a fast API server, right? Server through fast API. So basically you have imported this library fast API, you're creating instance of it, then you have added with the help of app.get slash, like it takes care of like all the get request to this particular slash is going to return this. Okay, fast API is running inside Docker. Okay, so this is the program is all about. And then there is another thing, app.get, and then you put the ID, it will just return the ID. So yeah, so this is smallest step. We don't have to go into this. Just I want to show you like what we are going to, like how we are going to run it, right, onto the container. So this is fine, right? And then this is the content of Docker file. Okay. So this is the content of Docker file. So we have some of the primitives or like some of the instructions that are thrown over here, right? Example, from, working dir, work dir, copy, run, copy, expose, cmd, right? So these are the different instructions that you have written in your Docker file, right? So first thing is base image. Base image is the smallest image, right? The base image is the smallest image that you can either refer, and there are different base images. Just like you can consider it as like operating system, mini operating system, right? That for example, we have this Python 3 Slim, right? So if you run this image, you will get a container that will only contain Python 3.12 along with some of its dependency, right? It may not have Vim, which is your editor. It may not have this service, let's say systemctl command. It may not have all the other general things, right? So it will be just like a bare minimum image with Python only installed in it, right? So you take this as a base image, right? And you start to build on top of it, right? So let's say your image is this Python 3.12 Slim, and inside this image, once this entire Docker file runs as a container, what you want, like so there will be the control, right? Once this container is running, what would be the working directory, right? Where your instructions, or what are the like wherever. So here you are writing this subsequent instructions, right? Docker instructions. You want to run it in a separate directory inside the container, in a separate sequence, right? In a specific sequence. So working directory is what it decides, what it says that, okay, once container is running up and running with this particular image, right? So it should run in app, in slash app directory. So this becomes a working directory. Then inside this working directory, you are going to copy the requirements.txt, which is present here, to slash app requirement.txt, this thing, right? Inside container, correct? This is what you are going to do. Then you are going to run, right? Run is directive. So copy directive, what it does, it copies from the like a host OS to the container, right? And then run is something which has instruction to like run all these run this particular command, right, which is nothing but it installs pip installed this instruction. And then copy is like copy dot to dot means you are like wherever the docker file is present, here it is present, right? So copy dot means the current directory, right? It copies entire thing to the working directory over here, right? So all of the files will be present over there under app. So this is what it says. And then expose is like when you are going to run the fast api application, let's say with any of the server, right? uvcon is again server. I think it's synchronous. Yeah, it handles synchronous requests. I'm not sure, like it may handle async thing as well. Yeah, so like it's just a normal server. When you create this Flask, sorry, not Flask, Fast API app, you can make it run through UVCon server, and then you can expose it via 8000 port. Okay.
Yeah, we have the
And
Gunicon and the UVCon server, right?
yeah, Gunicon. Yeah, yes. I just got confused with it. Yeah.
I think Gunicon is for Django. UVCon is in Fast API.
Right. UVCon is for Fast API,
For
but I'm not sure. Like
for Django, it's something like Python managed by Run server for Django. Okay. And Gunicon and UVCon server is the one which we use in the Fast API only.
right. Okay. Yeah. Cool. So yep. Thanks, guys, for chiming in. So yeah, through UVCon you are going to run your fast API, right? And then you specify the host and the port, correct? And expose is like how you want to expose the port from the container, right? So basically now the structure looks like this is your container, right? And it listens to the port 8000. It will be having app, right? And all the different like folder, right? That I shared, like that I shown you earlier, that it will have requirement main.py, app, router, module, database.py, everything over here. And then yeah, run command basically runs it, right? Run command will run and install all the requirements, correct? Whatever is there over here. And then you have CMD. So CMD is something like is sort of command line argument that you can override in another Docker file. So you can just override this particular thing. So in this case, like if like if you don't override, it will run this as default. So basically, this container is going to listen for the incoming request at the port number 8000. So once you so again, like this container gets an IP, right? It needs a network to run, right? So there are different type of networks. So ideally, like generally we run it in a bridge network, or we can also run it in a host network, so that this you can match this 8000 container port to your, let's say if this is the host, right? This is the server. You can match it to your, you can do port mapping to your host. So once you hit in your browser localhost 8000, the request from your host will forward it to the container, right? If in case you are using host network. So this is what the file is about, right? And yeah, so this Docker file, so what you do, so using Docker file, you specify the commands, and this contains the instructions to like how to create a like Docker image, right? So you do Docker build. So through this Docker file, it builds an image, right? And then this image can run a container, a running instance of it, which I am showing on the right hand side, right? So I think like it's we are like we are close to the time. So till now, if anybody has any questions, so I can take those questions, and then tomorrow we can, oh, oops, like sorry about that. Sorry about that. So tomorrow we can further continue from here. Oops, I accidentally unshared. I mean, I might have got closed, so it stopped sharing. Okay, so this is what it is, right? So we studied about Docker, right? Which is nothing but containerization. Then we checked like what are the differences in VMs and the container, and then we pretty much studied the foundational architecture. So again, this class is meant to be, I mean, for everyone, like just to make sure it was sort of a quick refresher so that everyone is in same page, right? When we talk about certain things going forward. So I don't want anyone to have like such kind of fundamental doubt. So I just wanted to make people understand. And then then we talked about few key components, how Docker run works, few of the kernel Linux aspects of it, like some of the key things the Docker is based upon. Then we talked all about the copy on write architecture of the file system that Docker uses, the entire Docker is written on. And then we talked about different Docker file, right? How to containerize an application, basically, how to write a Docker file for any application, right? So with the help of these instructions, and these instructions these instructions we are again going to revise tomorrow. Okay, what all these things are, what is the difference between command and entry point, like again another Docker instruction. Docker ignore, I've already talked about that. This is something which the unnecessary files that are generated during building your image, right? And you don't want some of these things to go, right? So basically, whenever you run your application in your local host, some of these build files or some of this cache gets created, right? So you don't want these caches to be preserved inside your Docker image, right? So that's why like some of this common cache, you can just remove it. So that's the use of Docker ignore. So again, like we are going to further resume the session tomorrow. So how far, like guys, anyone have any feedback? You guys like the session? Was it helpful? Was it less helpful or no helpful? I'm open to feedback, and let me know if you want me to improve anything, focus on anything else, right? So I'm not sure because I haven't talked to you one to one. So I apologize if in case there is any disconnect, right? So that's what I want to say. Okay, cool. I can see it was helpful. Okay, I can see a lot of likes as well earlier near the time I was talking. So I think we can. Oh, okay. Abhishek, yeah. Go ahead. Okay, yeah. Okay. I guess you have raised your hands accidentally.
Sorry,
Yeah,
Sankar.
so Ignal, yeah, I'm going.
Can you hear me?
Okay, yeah. Go ahead.
Yeah.
Yeah, I can hear you.
Sankar, I have one question. Like, will we be having any hands-on while developing, or it's only going to be theoretical?
No. Like it is going to be hands-on only, right? So theory again, you can chat GPT and get it. So we are going to do live things from tomorrow, most probably. So I just wanted to first, show the fundamental theoretical stuff so that you can reuse the same thing to ace your next interview, right? And then we
Yeah.
are going to see the practical aspects of it, and I'm also going to share the notes so that all of the things which you study in the class, make sure you replicate when you get a chance, right? So that's how we are going to operate. But yeah, theory, I feel it's very, very important, because see, if I show you everything on the fly on the very first day, it might not make sense, and you will not have anything to revise as well, right? So that was the intention. Yeah, just to answer your question, we are going to have both.
Sure. Thank you.
Okay, cool. So, oh yeah, Rahul. Yeah, go ahead.
So the first thing I just wanted to, we will be learning both AI as well as DevOps. So how the structure is being confirmed for that? I mean, how we have planned to plan for this particular session? How it's going to be there? Like we will be learning both AI as well as DevOps simultaneously together.
So I won't say that we are going to learn the entire DevOps, but in the DevOps we are going to learn Docker, as I said, Docker, and then Kubernetes 101, right? So so yeah, so these two topics specifically on the DevOps side, and then on the agentic AI we are going to build the application, right? So these three things are the agenda which we are going to cover in the weekend sessions for 2 hours every Saturday and Sunday. So I hope that clarifies you, right? So again, just to again clarify, not everything on DevOps, yeah, only Kubernetes and Docker. Okay. So today is like Docker session. Tomorrow follow up for Docker session. Probably kick start with Kubernetes components, and next weekend will be again probably follow up in the Kubernetes and then hands-on and theoretical stuff, and then we'll start with the agentic AI and stuff. Right? We'll see the core things on the Python. We'll talk about fast API. We'll talk about LangGraph, LangFuse, and then this LangChain, the OpenAI like model. So like as Shivansh and like a few other people suggested to use Grok, right? We'll check on those things and we'll build something together, right? That is meaningful and that is helpful for everyone. Okay. So anyone else want to say anything before we can call it a day?
A doubt here.
Okay.
So in the agentic AI part, so you will also cover the memory part as well?
Agentic part, no, I don't think so. Yeah, no, that is not included, Akhil. So on memory part only in terms of context window. So nothing like short-lived memory or long-lived memory, right? So there is something called as lang mem and stuff, correct? So are you referring to those things?
I mean, so
or
like how we will, so there is the concept called context window limit, right? So what
Yes.
we will
Yes.
be able, we'll also handle those cases as well, like if we hit the
Yes.
context limit, what we will do and all.
Yes. Those kind of things will be covered, but there is again a concept of short-term memory and a long-term memory. For example, like again, context window is short-term memory, right? So whatever like LLM processes, it sees the context window and gets the context, right? And there's something called as long-term memory. Long-term memory, let's say you are running agent for 2 years, last 2 years, right? So you have solved one issue last 2 years back. So how you are and now after 2 years you are again in the same shoes that you are facing the same issue again, right? So how your LLM is going to retrieve that particular issue, right? That was solved 2 years back. So that comes onto long-term memory concept. So again, there is something you can use long-term memory through Postgres by making by using Postgres extension PG vector. You can treat that database as a vector database, and then you can do some stuff. So
Basically, RAG
yeah.
will build RAG.
Yeah, exactly. You can say that. Basically a RAG. So those things, yeah. But we are not going to look into the RAG because we are not dealing on the documents and all those kind of stuff. But again, feel free to do that. And if you have any question, we can connect later as well, right? That's not an issue. So yeah, anyone else? Okay. I'll take it as a no. And I think we can call it a day. And I will share the notes. I'll share it to Shubham and the team, so they will share you. I'm not sure how these folks share the notes. So yeah, okay. Then take care, everyone. Have a great rest of the Saturday.
Thank you, Sankalp.
Yep. Bye bye.
Thanks.
Thank you. Bye bye.
Thanks, everyone.
Shankar, we will have a class tomorrow, right?
Sorry,
We will have a class tomorrow, right?
pardon me, Rahul. Yes, we will
I'm
have
saying,
class
do we have a
tomorrow,
class tomorrow?
same time. Yes, 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 yes,
Okay.
yes. We do have a
Thank
class
you.
tomorrow, same time. Okay. Bye, bye, bye. And meanwhile, please, guys, revise it.
Thank you,
Yeah.
Sankalp.
Thanks, man. Yeah.